There exists the theoretical algorithm, which is optimal algorithm to build intelligence, and I can actually explain you the algorithm.
Yes. Let's go.
And talk through O3 and the release, because I know a lot of people have been just scrambling about what to do with this. The metrics look crazy. Code Forces, it's like top of the world on Code Forces. Apparently this Arc AGI benchmark O3 is just crushing through where other benchmarks have failed.
But NVIDIA has sent 5090s, so the latest NVIDIA GPU, 5090s to the absolute swamp donkey AR hype content creators who, I mean, every video is this changes the world, and it's really, really frustrating to even watch. So NVIDIA, if you want to save your share price, please send Prime the latest 5090. So I thought I'd get my agents to create something like this for us. But I mean, this SpaceX has a lot of intelligent people and lots of money. But I mean, this to me looked a little bit ugly. So I'll quickly show you what our agents built for Eric. So I'll share this with them and give this to them. Let's see, 3-dimensional world for the portal. So there we go. So I thought this was a lot more pretty. Hi, welcome. So for those of you that don't know me, I'm Craig. I created Sheldon. So just a bit of background around me and Sheldon. So about just under a year ago, when all the AI hype started coming forward, I was really concerned about the vision and strategy of some of the major players in AI. And inevitably, there is a massive existential crisis coming when AI can outperform most humans at most tasks. So instead of sitting back and just waiting for this to happen, the sort of vision behind Sheldon was to create something that, instead of decreasing the value of human work, human interaction, and so on, is to create a tool that empowers any person at any skill level, any financial level, to be able to create exponentially more value and add more value in whatever they're doing, whether it's corporate, professional, personal, and so on. So the idea around Sheldon is to bring to people the most advanced artificial intelligence tools to every person, making it exponentially cheaper than anything that's currently out there or that will ever be out there, and better. So Sheldon, so maybe just some history on me. So I studied engineering at the University of Pretoria, and in my final year, I actually won the engineering competition at Pretoria for the design and construction and building, programming, and so on, of a wirelessly controlled smart car, which was programmed, I think that was C, primarily C. And in my second to last year, I came second for the design of a little autonomous robot using assembly. But if you take it back, when I started my studies, I actually started off with computer engineering. And after 1 year, I was convinced I'd never be able to understand programming, how this programming concept works. I was just struggling far too much. So I switched over to electrical engineering. And in the process of that degree, fell in love with programming. So yeah, that's a bit of my, let's say, history. And after 10 years in corporate, I decided it's time to bring Sheldon to the world and see if we can help people. So I spent the last 10 years in corporate in the manufacturing sector, in various roles throughout my career. But at the same time, I studied at the University of South Africa, management accounting. I also started a applied maths degree, but it was a little bit slow, to be honest. My passion has always been maths, as well as psychology. So throughout my life, I've been studying psychology, trying to understand it, for all the reasons that people study psychology, if I'm honest. So initially, because I thought I was too clever, if I'm honest. then for a very long time to try and help myself, and then to try and help others. And throughout my life, I guess it's been oscillating between the reasons, but it's always been a passion of mine, as well as maths. And then more recently, I've been diving into neuroscience, also doing quite a few courses on the Peterson Academy. So shout out to Jordan Peterson and Michaela Peterson and the Peterson Academy. There's some great content on there. Really enjoying it. So yeah, that's enough about me. So let's have a look at, or let's dive into the current state of artificial intelligence, what's currently going on, a lot of the hype and so forth. So I'm just going to quickly pop open. I got Sheldon just to create a streaming display for me to help me through this process. So let's get going. So a big reason, or why I'm starting this series, is to see if I can help the environment, help the artificial intelligence community. There's a lot of hype going on. There's a lot of false claims that now we reached AGI, and to be honest, I can barely stomach the current AI content creators. They're all following the hype train. Every single tool that comes out is changing the world. We've reached AGI, blah, blah, blah. So in these videos, I'll share a couple content creators that are actually worth watching. Okay, so let's have a look at what I see the current state of AI to really be. And nobody says it better than Denzel on the current content creators that are following the hype train, that the latest tool is changing the world and this changes everything, blah, 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 all that rubbish.
Yeah. What do you make of all the fake news that it affects?
If you don't read the newspaper, you're uninformed. If you do read it, you're misinformed.
So what do you do?
That's a great question. What?
So in this series, I'll go through I'll share parts of and unpack a couple content creators that I believe are actually worth watching. So first of all, a shout out to Prime. His content is really great, and he's a good human. You know, he's out there trying to inspire people, and when he takes on a new topic or evaluates something, he tries to be unbiased and actually understand what's happening. So yeah, definitely check out his channel, worth a look. But let's see what he has to say about O3 and their so-called ARC.
I just wanted to take a moment and talk through O3 and the release, because I know a lot of people have been just scrambling about what to do with this. The metrics look crazy. Code Forces, it's like top of the world on Code Forces. Apparently this ARC AGI benchmark O3 is just crushing through where other benchmarks have failed. So how about we take a look at it? And I'm just going to kind of go through what happened. And then on top of that, I'm just going to kind of give you my predictions about what does this mean for you now and what does this mean later. Okay, because I think it's pretty important to kind of understand this. So the first thing that obviously happened is if you open up Twitter in the last couple days, you're going to see just a bunch of BS tweets like this. AGI has been achieved internally.
And this is what's currently happening with all the latest tools that get released. You know, everything's hype now. This is AGI. This is going to replace everybody's jobs. And it's really not the case. So throughout this video, we'll unpack what it takes to build intelligence. What is intelligence? What is AGI? How can we create useful artificial general intelligence?
Internally, OpenAI says they're AGI. AGI, it's beginning to look a lot like AGI, right? And all of this happens because of this test right here. This is called the ARC prize test, right? The ARC AGI public and semi-private tests, in which are going to be a bunch of little logical puzzles, hoping that if you can solve it as an AI, this makes you AGI. And even though they...
First of all, it's so disappointing, to be honest, that ARC has so-called partnered with OpenAI and that they've even put this on their website as, you know, this massive breakthrough, because O3 does not qualify for the ARC challenge, and it is fundamentally against the vision behind the ARC AGI test. So it's very disappointing, but let's get into it.
They do claim that, hey, this isn't a 100% if you solve it, it makes you AGI. It's a litmus test in some sort to say that you're on the road or close to AGI. If you look at the results, you can see right away that O3 looks like it did massively better than O1 and even better than O1 Mini. And it effectively did by all comparisons.
Let's jump ahead a little bit just to have a look at what the actual tests look like.
Way down here, here's a 10% better and 20% better on these two with the high compute side. So what does one of these tests look like? I think it's really important to see one of these tests. If you go all the way down here, here's a test that had failed. Effectively, you see this gray square and the cyan square both have these like little pokies coming out of them, where the other three squares don't. And you'll notice that it moves over by the amount of pokies. If you do it again, cyan should move over 4, it does. Red should move over 6, it does. And then it asks the question, okay, what happens here? And unfortunately, the LLM cannot figure that out. For us, this takes, 5 seconds to realize what's happening here? Maybe 10 seconds. It's pretty easy for us. Well, a lot of compute and a lot of time and a lot of energy went into, and it was able to answer, 82.8% of them. So pretty good job. Pretty impressive. And honestly, when I first started out programming, I remember.
So maybe just to back it up a little bit there, let's have a look at the actual ARC challenge and some of the design requirements to submit your model or your approach to this ARC challenge. Okay, so let's go across here. So first of all, something that's fundamental, the whole concept around the ARC challenge is that you giving, in this case, like an AI agent or model, a task that it has never seen before. Right, so can it do something that it has never seen or thought of or been trained on before? So the first disappointing part is OpenAI trained O3 on how to solve these problems. So there's the public repository where you can, test out your approach and so on. And they, if you look at their, let's see if it is here, OpenAI O3 breakthrough. So here you'll see they say it's tuned. Okay, so they showed O3 how to, some of these examples, how to solve them and so on. So right there, it misses the point of this ARC challenge. Okay, and then one of the main fundamentals around intelligence and this ARC challenge, if we come down to the actual what you need to do to settle, what are the requirements when submitting a score, is the whole purpose around the ARC challenge is how can you create something that's intelligent using the least amount of compute, the least amount of resources, and so on. So the hardware requirements to submit to the official ARC challenge is that let's go through it quickly. So it needs to be on a base notebook where it has one NVidia P100, so 30 gigs of RAM, and 2 T4s, so and for the 30 gigs of RAM there as well for the GPU. So, and I mean, to run O3, you'll need about probably 1 or 2 terabytes of RAM. So it doesn't fall within the requirements of the ARC challenge. So it's really disappointing. And now they're claiming that this is AGI. First of all, reasoning is just a part of intelligence. It's not the be all and end all. It is an important part, but there's a lot more components which we'll unpack throughout this series and so on. So let's have a look at, interestingly, on Lex Friedman. Let me move across to this side. I struggle to say this gentleman's name, Wojciech Zaremba, who's actually one of the founders of OpenAI, defines intelligence. Again, shout out to Lex Friedman. His content is incredible, definitely worth a watch, as well as Wojciech Zaremba. I really enjoy it. Definitely watch this.
You can
video. I'll put the link to it in the description below. Definitely worth a watch. But I've just jumped to the part where Wojciech Zaremba defines the algorithm for intelligence.
Perfect compression if you store errors. And I think that actually what he meant is you have algorithm plus errors. By the way, Hatter is he was PhD advisor of Xianlek, who is DeepMind co-founder.
Yeah. So there's an interesting and now he's a DeepMind. There's an interesting network of people. He's one of the people that I think seriously took on the task of what would an AGI system look like. I think for the longest time, the question of AGI was not taken seriously, or rather rigorously. And he did just that. Like, mathematically speaking, what would the model look like? If you remove the constraints of it having to be, having to have a reasonable amount of memory, reasonable amount of running time complexity, computation time, what would it look like? And essentially, it's a half math, half philosophical discussion of how would it, like a reinforcement learning type of framework look like for an AGI?
Yeah, so he developed the framework even to describe what's optimal with respect to reinforcement learning. Like there is a theoretical framework, which is, as you said, under assumption there is infinite amount of memory and compute. There was actually one person before, his name is Solomonov, who extended Solomonov work to reinforcement learning, but there exists the theoretical algorithm, which is optimal algorithm to build intelligence. And I can actually explain you the algorithm.
Yes. Let's go. Let's go.
So the task itself, you can...
So I included the sections before, just as, if there's, for those of you that are interested, go check out those people, check out their work. But I'm going to try and explain as he goes through it, what is meant or how the optimal algorithm for intelligence works. So let's go.
Can I just pause how absurd it is for a brain in a skull trying to explain the algorithm for intelligence? Just go ahead.
It is pretty crazy. It is pretty crazy that, the brain itself is actually so small and it can ponder.
How to design algorithms that optimally solve the problem of intelligence. Okay. All right. So what's the algorithm?
So let's see. So first of all, the task itself is described as you have infinite sequence of zeros and ones. Okay. You read n bits and you are about to predict n plus 1 bit. So that's the task. And you could imagine that every task could be casted as such a task. So if, for instance...
So all he's saying there is any task or any challenge or problem that you're trying to solve, you can convert it into a format that an algorithm or a computer can use. So you can, let's say, take the actual question and you can convert that into actual bits, so change the words into their binary equivalent. Or if looking at a problem, vision, you can convert, let's say, the video or the image into a sequence of bits that represent that input, as well as the output. So whatever the desired outcome is.
Instance, you have images and labels. You can just turn every image into a sequence of zeros and ones. Then you concatenate labels, and that's actually and you could start by having training data first, and then afterwards you have test data. So theoretically, any problem could be casted as a problem of predicting zeros and ones on this infinite tape. So, so let's say you read already n bits and you want to predict n plus 1 bit. And I will ask you to write every possible program that generates these n bits. Okay, so and you can have you choose programming language. It can be in Python or C++. And the difference between programming languages might be there is a difference by constant. Asymptotically, your predictions will be equivalent. So you read n bits. You enumerate all the programs that produce these n bits in their output. And then in order to predict n plus 1 bit, you actually weight the programs according to their length. And there is some specific formula how you weight them.
So what he's saying here is, let's say you have some problem space. Okay, so I've just created a circle here to represent the problem. Okay, you have some desired solution, okay, of that problem. Okay. Then, assuming that all of your proposed approaches to generate the perfect solution are correct, okay, what he's saying here is if you look at each of these approaches, you weight them by size. So how big is the program? How much compute did it use? in, let's say, if we relate this to the current state of artificial intelligence, how big is the large language model? How long does it take, and so forth. Okay.
And then the n+1 bit prediction is the prediction from each of these programs according to the weight.
Like statistically, you
Statistically,
pick. So the smaller the program, the more likely you are to pick its output. So
what they've defined intelligence as, or a more intelligent system, or the most intelligent system, okay, is what is the smallest program or the least amount of, let's say, resource used to generate a solution, which is the fundamental approach behind the ARC AGI challenge. Okay, is can this solution run on a limited amount of hardware for a limited amount of time? Okay, so that definition, and that's how, when approaching Sheldon, I've kept that in mind as well. Okay. And that's why, throwing O3, which is a massively computationally expensive model, and again pre-training it on how to solve the task, is not general intelligence at all, and it is not the optimal or most intelligent way to approach that problem. So that's something to keep in mind as we go through the series and we try and unpack the various approaches to intelligence, etc. Is the most intelligent system will be the quickest, smallest approach that uses the least amount of resource, which in our case, in large language models and AI, etc., will be the least amount of compute and least expensive approach to still generate the perfect solution. That would be the most intelligent solution or approach to a problem. So that would be correct. This would be O3, which doesn't qualify. Okay, let's have a look at, now R1 has come out. There's a lot of, again, hype, etc. around R1. This changes the world, etc. So let's have a look at what Prime has to say about R1. And then let's unpack some of the good things about their approach. But also, it's not going to change the world. It's worth noting just how the market reacted to this model coming out. So if we look at the NVidia stock price, it was up at around $145 on January 23rd, and then dropped to a low of, I think it went down to about 116 at one point. There you can see the lowest was at $116. So it was massive. I mean, it was apparently around $600 billion of value was taken from NVIDIA in that single day. But it's maybe worth also just noting, if you look at where NVIDIA was, let's say just over a year ago, it was at $14.5 per share, and went all the way up to $145. So there's a massive increase in that share price. And if you look at just the volume of stock that was traded on this day, I mean, it was nearly $1 trillion that was shifted. Sorry, not $1 trillion, billion. No individual has that amount of shares to, it's not a whole bunch of people that are now thinking NVIDIA is worthless and so forth. It looks to me, and I'm not an investor, I don't have any of the facts, so please take this with a grain of salt, but it looks to me like a bit of profit taking. I mean, if you look here, it's just around May 2023, if you look at the volume of stock traded, somebody bought a lot of NVIDIA shares, and a lot of shares were then sold. So it looks to me like a bit of profit taking. Sure, people were scared or whatever the case is, but if we go back, I'm glad that this different approach has finally come out. I'm not glad that people have potentially lost money. Okay. But if we just go back and we look at OpenAI, let's say the beginning of 2024, or maybe a bit before, they were sort of punting the bigger models. Okay, everybody was doing that. These massive models, lots of compute, etc., etc., etc. But then, if you look at all of the top players, OpenAI, Google, DeepMind, and Anthropic, towards the middle of last year, they realized people, for 99% of use cases, you don't need massively expensive models. Okay, how can we make models smaller, more efficient, cheaper? That's what people actually want and need. Okay, that's where the use case comes in, and that is more intelligent. Okay. Again, we'll go deep dive into these approaches, etc., a bit later. But if you look towards or end of last year, end of 2024, and the beginning of this year, OpenAI has gone back to the big hype train. O3, massive model. They're not, following that same. Let's make it more efficient, more reachable. So it's a good thing, to be honest, that the environment is realized, or the AI ecosystem is realized, making absolutely massive models that no one can afford to use isn't the approach, isn't what's going to take companies to the next level, and isn't the way to build AGI. So let's have a look at what Prime has to say about DeepSeek.
I'm extremely excited about R1, not for the reasons why other people are excited for R1. Okay, the reason why I'm excited for R1 is actually quite simple. When I look at all this stuff, what I see is the availability for us to be able to actually have a model that is really, really good, that we can actually use, that you and I can actually use and put to use. Even some of the smaller models, yeah, they're not as good, but we can actually use it. And for me, that is really, really amazing. That's what I absolutely love. Like, I can go set up some sort of basic couple GPUs and be able to run even a decent sized model. It's not a great model, right? I don't need to spend $25,000. You could spend $1,000, get a good enough piece of hardware to be able to run something small and local. It can be completely offline, and you can have it just for you and be able to run it without having to worry about.
So I like Prime's or general, let's say, concept or his enthusiasm. But this is where I don't believe the future of artificial intelligence is going to be locally run or downloading and using models locally, for several factors. First of all, if you just look at intelligence, okay? So if you just look at what, or facts, okay? There's actually an algorithm which looks at the decay of, or the half-life of how long a fact has to be true, and then at some point it's proven that there's something, let's say, more true, or that fact is just incorrect. Okay, so let's say fine-tuning specific models that you have locally to do specific tasks and so on are fun in the short term, but as new technology comes out, new approaches come out, or you're trying to do a different or fundamentally different approach to whatever you're working on, that model then becomes obsolete, okay? Because that approach isn't the best approach anymore, or those facts, there are more correct facts that have come to light. And then secondly, if you just look at the rate at which models are coming out, we're at the stage where it's almost every maybe 2 months or 3 months, new state-of-the-art model comes out. And you always want to be using the best, latest models, okay? And in order to do that, your, let's say, memory, or your memory structure of how to do things needs to be separate from a specific model, and needs to be separate from fine-tuning and so on, so that whatever, regardless of the model you're using, you're still applying your use case, your memory, your strategy, your procedures, etc. And you're able to dynamically switch between what is the best, what is the most efficient model, or what is the best model to handle this specific task, and so on. So I'm not completely for running models locally. It is fun. It is. We've all done it. Anybody that's played around with AI has done it. There's a lot of useful learning that goes on in that process. But I don't believe it's the future of
about
artificial
all the other stuff, the
intelligence.
data collection, all of that, that actually seems pretty amazing. Like that actually seems like a huge W. And so I'm pretty happy about that. And that's actually what I want to see more of, is more of that, more ability to be able to run stuff myself without having to rely on OpenAI tracking and logging me. Okay, because they already steal all of our information. They already do all of that stuff, and it's actually pretty awful. And so the fact that I can take control, I can be the one, like OpenAI is not open. OpenAI is not the one that.
So again, so in our application, we use all the top providers, and we don't store any chats. And we don't, even if we look at OpenAI, so we are tier 5 enterprise customer. So we've disabled all of the ability for them to retain or train on the queries that we send through to them. But we also use Google DeepMind. We also use Anthropic. So again, by dynamically switching between the service provider and the model, you already start protecting yourself against your information being consumed. Then let's also just have a look at the actual release paper of DeepSeek. So as you can see, so Sheldon, we integrate to any of the drive systems. So I've got this paper saved in my business profile. So let's have a look at DeepSeek. I'm going to just jump right to the end. They look at the limitations. So some of the challenges around DeepSeek, okay, which make it less useful, let's say, is first of all, they state that it is very sensitive to the prompt, which I guess is true for all these models. But if they're having to put that forward, it's a bit of a concern. And then, where do they say? Yeah, I think importantly, they say currently the capabilities of Deepseek R1 fall short of V3 in tasks such as function calling and multi-turn conversations, as well as JSON outputs. The ability to effectively call functions is critical if you're trying to build anything that is generally usefully intelligent. So it's worth noting. But let's also then look at some of the so-called benchmarks that the DeepSeek model is claiming, as well as some of the good approaches, which I'm glad have, let's say, shocked the industry a little bit. But some of the more positive approaches to what they're doing. So let's see the approach with reinforcement. Where's their distilled models? Which one's this? This is the online evaluation. Zoom in so everybody can see. See. Okay. So let's go down to the distilled models. So something that they're claiming, which got everybody, let's say, excited, is that even their smaller distilled models, okay, are achieving great results on the various benchmarks and so on. Okay. So if we look at, I wouldn't suggest the 1.5B, it's just far too small. But let's say we take the 32 billion parameter model. There we go. It's getting great scores on these various benchmarks. It's a very small model and so forth. But something that's worth noting, okay, is that these distilled models were distilled using base models which were created for mathematics. Okay, so they are math-based models, and then the benchmarks that they've tested this distilled or distillation approach and this distillation model on is the math benchmarks. Okay, so it's worth taking the results with a pinch of salt. If you think this is a complete game changer. And if we look at as well, let's have a look. So here's the DeepSeek model card on Hugging Face. So let's go. Let me zoom in, make sure we can see. So first of all, if you want to run, let's say the full model, okay, which is, call it 700 billion parameters, you're going to need a GPU with a terabyte of memory, okay. So in terms of running it locally, I don't think anybody or most people don't have a GPU with a terabyte worth of memory. So you'll have to run it, on a cloud provider, etc. Something that is great and which is a much better approach is this, that it uses a mixture of experts, architecture. So what it does, instead of, as you pass your query through to whichever model it is, instead of every single parameter being computed every single time, the mixture of experts approach only activates a certain portion of the neural net that is applicable to what you're trying to achieve. So here they say 37 billion parameters are actually activated of the 670 billion full model, which is, that is why it is so much quicker to run, so much cheaper, and so forth. And is a much, in my opinion, is a much better approach to building these models, because it's a closer representation of how our brains work. Okay, so one of the, let's say, fundamental differences between these large language model neural networks and our brain is, in the large language model neural networks, every single neuron is calculated every time when you're trying to solve a certain problem. Okay, so even when you have a whole section of the network that is all sitting on zero, so it's not being used to solve the problem at all. It's, you busy solving in this case, let's say a math problem. All the emotional stuff, all the, let's say, storytelling, all the creative writing portions of your brain would not be activated at all. So they don't consume any energy, no computation time, etc. Whereas in large language models, those sections, even though they're completely deactivated, the actual multiplication, the dot product multiplication, gets computed every single time, which is why they're so computationally expensive to train and run, etc. Whereas what the mixture of experts approach does is, when your query goes in, it then splits between, okay, this is the portion of the neural network that is actually applicable, and then it runs that section. So it is a much more efficient approach to creating these neural networks. Obviously, there's a lot of nuance around that, which I won't go into now. Then let's have a look at the distilled models. So as I said, if you take, you can see it's the base model for each of these are math models. So it's models that were trained on to solve math problems. And then again, let's maybe go one step further. If we look at, if you want to run it locally, you're probably going to want to go a step further and get a quantized version of that model. Okay, so if we have a look at here, this is the 32 billion parameter model. If you want the full model, you're looking at around 65 gigs. So to run the 32 billion parameter R1 model, the full model, you're going to need at least 100 gigabytes of GPU memory, which again is massive. But you can get a distilled version, which a lot of the content creators and Prime is looking at using. So what that does is, if you can imagine each neuron with its weighting, okay, as a number, let's say 0.1, 2, 3, 4, 5, 6, 7, etc., and it carries on for a while. When you're using a quantized version, okay, it's taking that precision, okay, and chopping off a lot of the last couple, let's say, decimals. Okay, so if you're going to go for, like, let's say, if you go for any of the quantized models that have, let's say, this in their name, you've taken that full 16-bit precision and you've dropped it all the way down to 4 bits. So you're not getting the full capabilities of the model. So it's just something to be wary of. If you trying to run these models locally, and there was a lot of hype around, oh my gosh, this changes everything. You can even run these locally. You need to be aware that, first of all, you're not even running the R1 model. Okay, you're running another base model that was distilled or trained on the outputs of the full R1 model. And then if you're going to go down to a quantized version, you're losing the precision of the neural network. So, and there's a couple papers, if anybody's interested, you can shout in the comments. I can unpack that a bit further. But for most use cases, that'll be okay. But you're losing a lot of the, let's say, broader memory, the outliers, the nuance around how to do certain tasks, etc. You are going to lose. So you need to be aware of that. Okay. I think that's about it for R1. But maybe something that is worth saying. Again, check out this full video. Pram does a great deep dive into R1, etc. His thoughts are worth checking out. But something, I think this will, NVIDIA, if you're out there, if you want to save your stock price, check this out.
There's no way to convince someone that you should get an allocation of one of these, of an FE card or something.
I would feel bad doing that.
Okay, fair enough.
So I'm just keeping this little piece of this video. Again, check out Prime's channel, great content. But NVIDIA has sent 5090s, so the latest NVIDIA GPU, 5090s to the absolute swamp donkey AI hype content creators who, I mean, every video is this changes the world, and it's really, really frustrating to even watch. So NVIDIA, if you want to save your share price, please send Prime the latest 5090. It might not, let's say my core belief or vision around where the future of artificial intelligence is going, it might not be the same as his in terms of running models locally, but the content that he will create using that card will be balanced. It will actually be informative and actually help the AI ecosystem versus all the current hype content creators. You know, if you look at, let's just take Devon, for example. It was so hyped up, right? And then they got bought at a silly valuation. And let's say 6 months later, when they actually released their Devon product, it was unusable. It was absolutely useless, you know. So, and what does that do to the ecosystem? People, companies, or individuals that want to start adopting these tools, all they see is, oh, this was so hyped, and then when you actually try and use it, it's completely useless. And it's really not, it does not help the ecosystem at all. So please, NVIDIA, if you want to save your share price, I guarantee you sending Prime a GPU will help. And again, I'd rather watch Prime giving an honest, insightful breakdown using the various models, tools, etc., where, you know, it's actually, you actually learn something from it. It is not hyped, it is honest. So I thought I'd just sneak that in there to hopefully get Prime a GPU versus some of the other swamp donkeys out there. So let's have a look at why did we create Sheldon? What's the vision behind it, etc. So I'm gonna use Jelly Roll here to help me explain our vision and some of our key principles.
1,000 people to thank you, but most importantly, my Lord and my wife. I love you so much. You changed my life, baby. Megan, Parker, Haley, I love all y'all. We're friends. And Zach Bryan, I think you are one of the hottest things on earth, not just country music. You deserve this as much as anybody else. I love you. I'm glad we're sitting there partying the rest of the night, baby. But most importantly, there is something poetic about a 39-year-old man winning New Artist of the Year. I don't know where you're at in your life or what you're going through, but I want to tell you to keep going, baby. I want to tell you success is on the other side of it. I want to tell you it's going to be okay. I want to tell you that the windshield is bigger than the rearview mirror for a reason, because what's in front of you is so much more important than what's behind you. Let's party, Nashville!
What a legend. So, I mean, it's an inspiring video, but the idea of how can we give everybody, regardless of who you are, what your skill set is, your financial position, your technical or computer capabilities are, how can we give every single person the ability to do it, to achieve their goals? And, you know, in the future, where we're going to face this massive existential crisis where potentially artificial intelligence can do almost anything better than a human, how can we give each individual a tool that is exponentially better than, let's say, what is being given to corporate, what is being given, or what massive firms that have huge financial backing? How can we create a space to empower every individual to be able to learn, deliver, achieve tasks, and create a much higher personal existential value versus just removing it completely and saying use AI, AI can be better? So how can we make individuals better than being replaced by artificial intelligence? And that was the design approach that we used. So, you know, if you have, you know, a fleet of agents, you know, through Sheldon that make or empower you to do so much more than if you were just, let's say, replaced by some AI model. So, I mean, if we look at, let's say, Devon, which is currently $500 a month and can basically, basically is useless, okay, and is supposedly replacing software developers, etc. And it also has limitations on how much you can use it, etc. And let's get real, most people can't afford an additional $500 a month, you know, to help them in, let's say, their software developing jobs and so forth. Whereas when I started, so I built Sheldon using Sheldon. Okay, so initially, I actually started building this framework before large language models, which was a complete mess. It's pretty dark. It's massive, massive equations, etc. But it helped me develop a way of understanding, thinking, intelligence, and so forth. And then when the AI hype started coming out, I'd never programmed Python. I'd never programmed JavaScript, HTML. I'd never built a web application at all. So initially, the easiest way to, let's say, get a working application was I transferred. Initially, I was working in Octave, which is like a mathematical language and program. So I learned Python and built a desktop application simple version of Sheldon, to then start using Sheldon to build Sheldon. And then I built the entire application, and the application grows using my Sheldon agents, or front end, back end, etc. And if I just take my personal story, when I started this, I've never, like I said, I didn't know anything about JavaScript, how to build a web application, and so on. And in a couple months, I've fully, it's, if I may say so myself, it's pretty beautiful, the way it works, the way it can dynamically change, etc. So, you know, that is the vision behind Sheldon, is how can, you know, in this example, taking someone that doesn't, like, has zero skill in a certain task, and being able to develop an entire web application from scratch. So that, and I mean, if you look at the pricing, so our standard package is $20 a month, and you can have 40 or 50 or whatever it is agents working for you. That is a lot more useful and a lot more reachable to most people. And if you look at, let's say, the latest hype is OpenAI. Let's see, OpenAI Deep Research. Okay, which again, the hype content creators are saying it's the first glimpse of AGI, etc. But again, if you go down to the pricing, you have to be a pro user, so $200 a month to use this deep research functionality. And even then, you're limited to 100 requests a month. So you're paying $200 a month for this tool. And then you can request, put 3 requests through a day, which just shows, let's say, the architecture behind it isn't the optimal approach to intelligence. And if you have a look at some of their benchmarks, so for example here, the GAIA benchmark, which is like an agentic benchmark. So even if you look at, let's say, just a watch out for all the hype around benchmarks, and all the companies are doing it to some extent. So they say, yeah, okay, cool, they've got 67%, or actually if we go here, 74% on level 1 on this benchmark, 69% level 2, 47% level 3, etc. But if you actually go across to that website, which is in there, if you go to the link, you can follow the leaderboard link. And if you look at the actual results, they're first of all far lower to what's on the OpenAI website. And again, it's not even, let's say, the best results on this benchmark. And then, I mean, just for fun, I downloaded the benchmark data set to try out a few queries, which I'll just show a quick example. So like the one question is, can you find the winner of American Survivor that was born in May? Okay. And if you look at, they give a breakdown. So apparently it took almost an hour to find this answer, and it was between 40 and 60 steps, they say. Whereas, I mean, if you just use the basic web search capability within our application, which is available to everybody, a task like this, you'll see our agents will be able to solve it very quickly. There we go. So there it's done, search the web, it's found the person, that is the correct answer for anybody that's interested. It's given all the references, etc. And we don't have a limit on how many times you can use that or use this capability a day. Here's, let's say, all the links if you're interested. You want check out the various links. And I mean, this web search and interaction capability we developed. It's about 6 months ago. We already had this working perfectly. So all this hype around AGI and some of the tools that are coming out really isn't validated. I also did, and this is supposedly a level 2, so one of the harder tasks. And I mean, you saw how quickly this was done. One of the other more interesting ones was one of the questions are files. So they attach this picture of tub of butter or ice cream or something like that, and then it asks a question around what's the fat percentage or something above the American national standard. So, and I mean, so again, it's just another one I tried out, and I put it up the complexity slightly. Now you can see it creates a full, let's say, specifications report, works it all out, does the calculations. So I don't know if you'd really want to spend $200 a month to put 3 requests through a day, versus again, our whole architecture around intelligence and how to create something useful is optimized for performance and accuracy. So that's how we can offer this capability at $20 a month with very high usage limits. And if you want to really go crazy and go for the $40 a month, where within our professional plan for certain tasks we are using then the O3 mini model, we use GPT-4o throughout, etc. We use all the top models for the specific tasks when they are required. So it's just something to watch out or be aware of, around all this hype, around the latest tools and use cases. I definitely would want to spend $200 a month and be limited, So let's have a look at what the DeepMind CEO has to say around the path to AGI, which I think is very informative and insightful. And let's have a look.
So every research house right now is working toward building AI that mirrors human intelligence, human level intelligence. They call it AGI. Where are we right now in the progression, and how long is it going to take to get there?
Well, look, I mean, of course, the last few years has been an incredible amount of progress. Actually, maybe over the last decade plus. This is what's on everyone's lips right now, and the debate is how close are we to AGI? What's the correct definition of AGI? We've been working on this for more than 20 plus years. We've sort of had a consistent view about AGI being a system that's capable of exhibiting all the cognitive capabilities humans can. And I think we're getting, closer and closer, but I think we're still probably a handful of years away.
Okay. And so what is it going to take to get there?
So the models today are pretty capable. Of course, we've all interacted with the language models and now they're becoming multimodal. I think there are still some missing attributes, things like reasoning, hierarchical planning, long-term memory. There's quite a few capabilities that the current systems, I would say, don't have. They're also not consistent across the board. They're very, very strong in some things, but they're still surprisingly weak and flawed in other areas. So you'd want an AGI to have pretty consistent, robust behavior across the board, all the cognitive tasks. And I think one thing that's clearly missing, and I always had as a benchmark for AGI, was the ability for these systems to invent their own hypotheses or conjectures about science, not just prove existing ones. So, of course, that's extremely useful already to prove an existing maths conjecture or something like that, or play a game of Go to a world champion level. But could a system invent Go? Could it come up with a new Riemann hypothesis? Or could it come up with relativity back in the days that Einstein did it with the information that he had? And I think today...
So I think this is, it's a much more realistic viewpoint of where artificial intelligence currently is and what the roadmap looks like. So I'll also link the full video in the description below. But something that he mentioned, which again no large language model on its own will be able to achieve, is this proper memory structure, whether it's long-term, short-term, working memory, and this ability to plan and work over time. For a lot of tasks, they aren't something that you're going to complete in, let's say, one pass or one request through. You might need to wait for some information, check an email, interact with a coworker, build a certain portion of it, come back and look at that. So it's maybe a bit of a teaser for some of the content or future videos that I'm going to put up, is how we've gone about creating that. How can these models what we've done is we've created a full memory structure which is a mirror of the human memory structure, as well as how retrieving, accessing, updating those memories work, as well as then how can we give the agents the capability to work on things over time, over a day, over a week, over a month, and so on. Again, accessing those memories, the various data sources and so forth. But something interesting that he said there, which is very, very true, and something that I'm struggling to conceptualize at this stage is how can these models or a framework come up with something completely new, completely unique. So again, a teaser for something that I'm busy working on putting together is, how can, if you take Eric Weinstein, who's a absolute legend in my opinion. I think he's obviously super intelligent, as well as it seems like a great human. But he came up with this approach to the theory of everything, which I believe is a much, much better approach and has a greater chance of being correct than what's currently done, let's say, in string theory, etc. But he came up with that when everything, all the knowledge, all the content on the internet said that you, in order to come up with a theory of everything, go this way. So how can you, what is the thought process and way of, understanding all of that, but then coming up with something completely unique in a different, taking completely different approach, which is also then correct, or which will, fundamentally be correct once completed. So maybe this is a nice segue. Just again, a shout out to Eric Weinstein. So I'm a huge supporter of his, and also recently they have this website, the portal. So one of the fun things they have on there is, you can help out this community, and they had a few programming questions where they wanted some help. So just the fun one, which I quickly got our agents to do, is they have this portal map. Let's see. So they have, let's see. So this portal map, this is what the website currently looks like, where they, put a few fun locations, etc. And their question was, how can we change this to look more like the SpaceX website, okay, which is 3D, obviously. So I thought I'd get my agents to create something like this for us. But I mean, this SpaceX has a lot of intelligent people and lots of money. But I mean, this to me looked a little bit ugly. So I'll quickly show you what our agents built for Eric. So I'll share this with them and give this to them. Let's see, 3-dimensional world for the portal. So there we go. So I thought this was a lot more pretty. It's a 3D world, and then it also links to, let's say, the backend data structure, where you have, let's say, all your various points coming through. And then just for fun, I thought I'd also maybe put a pretty image in there as well. So this was one of their points. Apparently, this is the palace of Master Ugwe, and then I've generated what I thought would be an image of him. So again, I mean, instead of $500 a month or something like Devon, our agents went, and I can also unpack how exactly. I'll do a video on, let's say, creating this capability for them. But to me, this is the future of, let's say, there's this hype, or people are talking about artificial intelligence replacing developers. My gut feel is developers are going to be one of the last to be replaced, because there's all the nuance and understanding of, let's say, the vision of the task, the company, etc., as well as all the technical best practices specific to that company, that application, etc., which are maybe undervalued. I see developers working like I am. Sheldon builds Sheldon, but where you could have, let's say, non-technical or non-devs coming in is creating maybe custom displays or custom or simple interfaces or websites, etc. So I showed that example now of let's say the portal. I saw there was some hype around a chess company, so I got my agents to build a custom display to play chess. It also uses the chess engines. And I thought to make it pretty, 3D chess pieces. So, this type of thing I could see, let's say non-devs, asking an AI tool or application like this, hey, I want to see this in my current, let's say, full data framework, web framework, etc. But can you create this on top of what's existing? So, and just for fun, in this, I thought it would be cool to show, track the strength of, how you're doing, and like what would the best move be, correct move, wrong move, whatever. So, something that's where I see non-developers playing a bigger role in development of software. But I don't see developers getting replaced by artificial intelligence very soon. And if they are, it would be a bit short-sighted, and I'm not sure what the results would look like. So so that's maybe, let's get back to our unpacking the rest of what the current state of artificial intelligence looks like. Maybe, actually, I think what I'm going to do is, we've been on for quite a while now. I'm going to leave this to the next video, where, again, shout out to Steve. His content is great. He creates at Builder.io. So I'm going to go through some of the points where he discusses the future of artificial intelligence, the current state of artificial intelligence, how to use the different tools, etc. And I'll go a bit deeper into some of the correct approaches to agentic frameworks, to memory, and so forth. But if you enjoyed this content, hit a like and subscribe to this video. And we'll see you soon.